Monte Carlo methods play a crucial role in energy systems by helping engineers and policymakers manage uncertainty, optimize operations, and improve efficiency. Energy systems involve numerous unpredictable factors, such as fluctuating demand, renewable energy variability, and equipment failures. Monte Carlo simulations allow researchers to model these uncertainties and make data-driven decisions. Why use Monte Carlo in energy systems? Energy systems are complex and influenced by multiple uncertain variables, including variability in electricity demand and consumption patterns, unpredictable generation from renewable sources like wind and solar, equipment reliability and failure rates in power grids, market fluctuations affecting energy prices and fuel costs. Monte Carlo simulations help by estimating energy demand under different scenarios, assessing the reliability of power grids and generation systems, optimizing energy storage and distribution strategies. Key applications of Monte Carlo in energy systems. Monte Carlo methods are widely used in various areas of energy management, including renewable energy integration. Monte Carlo simulations help model the uncertain nature of renewable energy sources by estimating power generation from solar and wind farms under different weather conditions, analyzing the impact of renewable variability on grid stability, optimizing battery storage and backup systems for energy reliability, power grid reliability and risk assessment. Monte Carlo techniques are used to assess grid performance and minimize outages by simulating equipment failure probabilities and their impact on the power network, evaluating contingency plans for power blackouts, optimizing maintenance schedules to prevent unexpected failures, energy pricing and market forecasting. Energy markets are highly volatile, making pricing predictions challenging. Monte Carlo methods assist in forecasting electricity prices based on supply and demand fluctuations, assessing the financial impact of energy trading strategies, evaluating investment risks in power generation projects, energy storage and distribution planning. Monte Carlo simulations help optimize how energy is stored and distributed by determining the best locations for battery storage facilities, managing fluctuations in energy supply and demand in smart grids, improving efficiency in transmission and distribution networks, carbon emission and policy analysis. Governments and industries use Monte Carlo techniques to estimate the impact of carbon reduction policies, assess risks associated with climate change and energy production, develop sustainable energy transition strategies. Challenges of using Monte Carlo in energy systems. Despite its benefits, Monte Carlo analysis in energy systems has some challenges. High computational cost for large-scale simulations. Dependence on accurate data for reliable results. Difficulty in capturing long-term trends in energy transitions. Conclusion: Monte Carlo methods have become a vital tool in energy systems, helping stakeholders make informed decisions about power generation, grid stability, and renewable integration. As energy challenges grow, these simulations will continue to play a critical role in building a more reliable, efficient, and sustainable energy future.